We are looking at section 3.3, which is modeling with functions. So we're going to be using a different notation in this class from now on. So typically when we have an expression, we don't have an equal sign. When we have an equation, we use y equals. And when we have a function, which is new, we are going to use f parentheses x. And how we say that is f of x. But what I want you guys to know is that it's really just the same thing as y. So I'm going to, right here on this star, we use function notation. The reason why we have it is to denote that something is a function. So we're going to use function notation, which is really like the f of x when we have a function. So first let's look at, again, what x and y are, or again, x and f of x. Again, think of f of x as just like another y. So x is your input, but we are going to go a little bit further now, and we are going to call it our independent variable. So it can stand on its own, whereas y definitely depends on the x. So we know that y is our output, and it's going to be considered our dependent variable because whatever y is will depend on what we input for our x. So we're going to look at some modeling using function notation. So the first problem we have, Amanda babysits and charges $50 per hour. So the first thing we want to decide is what our function is, and I think we can all come up with it pretty easily. So if we were doing an equation, we would say y equals 50x, but for our function, we're going to do f of x equals 50x. And then we want to kind of state what our independent and dependent variable represent. So remember, independent is your x. So looking at this, since it's 50 times x, x represents the hours worked. So sometimes it's actually easier to write your function first and then come up with it. So for example, if I do 50 times 3 hours, that will give us the answer. So that must mean the answer is the amount of money earned. And this makes sense because the amount of money earned depends on the amount of hours worked. So again, y is always dependent. So here's an additional problem going along with this. It says find f of 4. So when it says to find f of 4, it just means to evaluate the function when x is equal to 4. And in this case, we're finding out how much Amanda will make when she works for 4 hours. So f of 4 is just 50 times 4, which is 200. So that tells us that Amanda will make $200 when she babysits for 4 hours. Okay, looking at the next problem, we have a lawyer's fee is $180 per hour. How much does the lawyer make in 5 hours? So you can see we're asking for the function again. So if it's easiest to come up with the equation first, you could do that. So our equation would just be y equals 180x. So our function is going to be f of x equals 180 times x. So thinking about this, what the independent and dependent variable represents, well, we know independent is x and dependent is y, or f of x. So for the independent, it represents the amount of hours, again, hours worked. And for the dependent, it represents the amount of money earned, once again, because the money earned depends on the hours worked. So it asks how much does the lawyer make in 5 hours? So what we're going to really do is evaluate the function at 5. So you do f of 5 equals 180 times 5. So 180 times 5 is 900, which means that the lawyer makes $900 in 5 hours. So this next problem is a your turn. So what you would do is pause and do it on your own, and then I will go over it after. So we have Kate earns $7.50 an hour. How much money will she earn after working 8 hours? So our function is f of x equals 750x. So again, independent is x, and that represents the hours worked. And dependent is y, or f of x, and that represents the money earned. And now we need to answer our question. So if Kate works for 8 hours, how much money will she make? So since our function is f of x equals 750x, we're going to evaluate that function at 8. So f of 8 equals 750 times 8. And 750 times 8 is 60, which means that Kate will earn $60. Okay, so now that we've looked at 3 different examples of modeling, we're now going to evaluate using function notation, which should seem very easy since we were kind of already doing that. So this is really just like equations, and you're evaluating the function at a certain number. So the first one, we have the function f of x equals negative 2x plus 3, and we want to find f of 3. So what that means is wherever you see an x, you're going to put a 3. So it will be negative 2 times 3 plus 3. So negative 2 times 3 is negative 6, and negative 6 plus 3 is negative 3. So that means that f of 3 is negative 3. The next one, we have f of x equals 5x minus 7, and we want to evaluate the function at negative 4. So we're going to do f of negative 4 equals 5 times negative 4 minus 7. So 5 times negative 4 is negative 20, and then minus 7. So we end up getting negative 27, which means that f of negative 4 equals negative 27. And our last topic is reasonable domain and range. So what this means is we already remember domain is all possible x values and range is all possible y values. But we're going to be finding domain and ranges based on a certain situation. So we have Maya has $600 saved and adds $50 per week for 6 weeks. Okay, so she already has $600 and then she's adding $50 per week. So our function is going to be f of x equals 600 plus 50x. And how we're getting that, 600 is an amount that is set. We're not changing it, but 50, we are changing it based on the amount of weeks that she saves the money. So one other thing that will be helpful when we find our reasonable domain and range is to identify that x represents the amount of weeks because it's 50 times x, so that will be 50 times the amount of weeks, which means that f of x, or y, will represent the amount of money earned. So looking at this, the x is the domain, so x represents the amount of weeks. Well, we have a set amount of weeks. She's going to be doing this for 6 weeks. So a reasonable domain, technically at the 0th week, or when she starts, she has $600. And then from there, we have the 1 through 6. And we're just doing whole numbers or positive integers. All right, the next one is reasonable range. So we know that the range is the f of x, or y, which represents the amount of money earned. So she has $600 in week 0, and then from there, she's going to keep on adding $50. So week 1, she has $650. Week 2, she has $700. Week 3, $750. Week 4, $800. Week 5, $850. And week 6 would be $900. So that would be your reasonable range. So you could have evaluated that at each of the inputs, but it's kind of easier just knowing that you're going to add 50 each time.